Hello everyone, welcome to my YouTube channel. So here today we are going to be looking at application of logs and exponentials. So under this topic we are going to solve all these problems. So these are very likely to come in an exam. So now, what are we talking about? So we know that the simple interest is equal to the principal times rate times the time. So this is the formula for simple interest. So now it is known that, let's say for example, if you have 10% interest, then let's say this is your rate, which is your 10%, then you have your time, let's say to 1 year. So let's say the time is 1 year like that. Then let's say you have your principal, which is the money you have put in. You have put in about let's say 100 kwacha. Then the other thing that we have is, let's say we are required to calculate the interest. So we have the interest, it shall be equal to the principal, which will be equal to, we have 100 kwacha times the rate, which is 10%, and a percent is always out of 100, times the time, which is 1 let's say year like that. So when we do our math, our interest will be equal to, we have that. So the percent cancels. We are going to have 1 by 10. It will be 10 like that. So that means to say you have made the interest, which is 10 kwacha. Now after 2 years, let's say after 2 years, so the only thing that will change, let's say time is equal to 2 years now. So after 2 years, you will make something like the interest will be equal to principal times the rate times the time, which will be equal to, the interest will be equal to the principal, which is your 100 kwacha, times the rate, which is 10% over the 100, then times the 2 years. So this is going to give us this, and this cancels, this and this cancels. We have 10 times this. Your interest will be equal to 20 kwacha. So now this is simple interest. Now this is not really fair, because the bank is using your money. Therefore, your money should not be increasing like this. It is just increasing by the same amount. After 1 year, 10 kwacha. Another year, there is an addition of a 10 kwacha. No, it doesn't work like that. So there will be need for you to have what we call compound interest, whereby the money that you are going to be getting will be dependent on how the spatial sum is coming into play. To explain this, let's take this as our example. So for it is given as your A should be equal to 1 plus your R to the power of T like that. So principal times 1 plus R to the power T. So where our A is the amount that accumulates. So the amounts that accumulates over a period of time. So that's our A. Then our P is the principal value, which is the value that you put in. If you started with 100 kwacha, that will be your principal. Then we know what our R is. So our R is our rate, then our T is our time. So with this said, so let's say for example, if you put in 100 kwacha like that, so it will be, if the rate is 10%, it will be 10%. Now 10% is the same as 10 over 100. That's how come we have 0 point. If we add another 0, it will be 100 divided by 100, it is 1. So that's how come we have 0.1 like that. Then what we are going to get is 1 plus, you add 1 plus this, it is 1.1. Then to the power 10 gives you this value, of which I'm just explaining. You don't have the calculator, so they can't ask you something like this. So now, what does this mean? So it means that for the first month, so this person, this 1 plus, so 1 plus the interest is the amount it will be multiplied by. So this means that for the first month, you realize to say this person made a 10 kwacha, which is normal. So we have a 10 kwacha like that. Now, as time proceeds, as you can see, from 10 kwacha it has become, instead of adding the 10 kwacha here to make it 120, we have a 121 like that. Then when we look at here, 121, that means to say 11 kwacha was added. So we have, for you to move to the next one, we have 11 kwacha was added. So 110 plus 11 is 121. So 121 plus 131 here, what was added in the actual sense is 12.1. So as you can see, when you add 12.1 to 121 plus 12.1, this will give us 13.31. So this will be 133. Here what is added is a 13.31. So 13.31 is added here. Then as we proceed like that, more and more money is being added to the extent whereby we have our 161.05. If we look at the amount that was added, we have 161.05. Now I'm just doing this to explain a point. So that is the type of interest that we want when you're doing a business. So now imagine if you're working with 1,000, even something like 10,000. That means to say it will be accumulating. For the first time, if it is 10%, it can only accumulate to about 11,000. Meaning to say you have gained 1,000. The next month it might be a gain of about 500 more. So that is the goodness of banking in that aspect. So now that is the way it works. So it is very applicable like that. So now let's begin answering the problems. So looking at our first example, we have finds the total amount accumulated in a bank if the initial sum of 1,000 is invested for 2 years at the rate of 5% per annum. So we are going to say find the total amount accumulated. So we are going to say A is equal to, we have principal times, we have our 1 plus the rate to the power time. So we have our A should be equal to, what is our principal? So the initial sum is the principal. So we have 1,000 like that. 1 plus 5% is the rate. So we have 5% over 100. The percent is always over 100 to the power our time. Then we are told for 2 years. So 2 years, we are going to say 2 there. So we have our A should be equal to 1,000 like that. Then we have 1 plus 5 divided by 100 is, so this and this cancels. It will be 0. You add a 0. So let me just create space. You add a 0. 50 divided by 100 is still 0. You add a 0. 500 divided by 100 is 5. So we have the power of 2 like that. So our A should be equal to our 1,000 like that times 1 plus 0.05. It's 1.05 to the power of our 2 like that. Then just multiply your 1.02. So what you can do is remove the decimal point like this, so that you have your 5 by 5 is 5, remainder 2. 5 by 0 is 0 plus 2 is 2. Then 5 by 1 it is 5 plus 2 is 7. 0 by 5 is 0. 0 by 0 is 0. 0 by 0 is 0. Then the last one, 5 by 1 is 5. 5 by 0 is 0. 1 by 1 is 1. So that we have our value, which will be equal to a 5 when we add them, plus we have a 2 here. Then 7 plus 5 gives us 12. So we have a 2 like that. We have a 2. Or on multiplying, we added again 5 by 1 instead of just the 2 was affecting there. So we have a 5 here, then we have 5 plus 5 is 10, so 0 remainder 1, 0 plus 0 is 0 plus 1 plus this one is 1, so we have this value. So this is the value that we have. So what we are going to do is that since the decimal point was here, so 2 numbers before the decimal point, we have to move 1, 2 for the first number and also 1, 2 for the second number. So it will be like this. So this is the value 1.1025. So this is the value there. So our A should be equal to 1000 times 1.1025. So multiplying by 1000, 1000 moves the decimal point 1, 2, 3. So our A should be equal to 1102.5 like that. So this is our value for that one. So this is the money that's accumulated over that period. Let's move on to our next problem. Let's say we have this. What rate of interest is needed for an investment of 1000 to yield this in 2 years if the interest is compounded annually, meaning per year? So we are going to say our A should be equal to, we have the principal, open brackets, 1 plus our R to the power of our T. So if it is to yield 2000, so we are going to say 2000 like that should be equal to the principal, which is the amount that we have there is 1000, then 1 plus the rate, which we don't know, to the power of our T, which is our 2 years like that. So divide your 1000, divide your 1000, this gives us a value of a 2 should be equal to 2000 divided by 1000 is 2, should be equal to 1 plus our R to the power of 2. So what we are going to do is that we are going to get rid of the power by introducing the square root on both sides so that this and this cancels. So we have the root of 2 should be equal to 1 plus our R like that. So remember, they have given us an hint. The square root of 2 is 1.41. So you should also just know this one. So the square root of 2 is 1.41 should be equal to 1 plus our R. So taking the 1 the other side, it will be 1.41 minus 1 should be equal to R. So our 1.41 minus 1, it will be equal to 0.41 should be equal to our rate like that. So this rate of 0.41 can also be written as just the number 41, then add a percent, because we know that the percent is out of 100. So if you say 41% over 100 percent, this will give you 0 point. If you remove this percent, it will be, you add a 0, it will be 4. Then after that, the remainder will be the 10, you add a 0, it will be 1. So it's either 41% or 0.41, whichever is very much alright. So now remember, they have said that it is compounded annually, meaning to say per year. So there are cases in which we are going to be having the compounded more than once. So when we have compounded more than a month or a year, sorry. So compounded more than a year, the formula changes. So if it is compounded more than a year, meaning to say instead of just getting once in terms of the interest, or rather the increase, you are going to find that there will be an increase, maybe 2 times, 3 times a year. We use the formula. The formula changes to A should be equal to the principal, open brackets, 1 plus, then the rate over the n, like that, then to the power of n times the time, like that. So this is the change if it is compounded more than once, like that. So let's solve more questions. So if we have this one, 700 is invested for 5 years at 6% per annum, compounded semi-annually. Determine the amount produced. So semi means half. So half of the year, if you have to compound half a year, so 2 times, that means to say you are going to compound it on semi-annually, means to say, let's say June and the end, which is the December, meaning to say you are going to compound it twice. So semi, when you see semi-annually, it means to say 2 times, because semi is half. So we are going to have this, we are going to say our A should be equal to the principal times we have our 1 plus our R, 1 plus our R over N to the power of NT. So we have our principal. Okay, we are calculating, determine the amount produced. So we are calculating the amount, which is our A, should be equal to the principal is 700. Then we have times 1 plus, what is our R? So the rate is 6%, like that, over the N, which is our 2, like that. Then our N, which is the number of times it is compounded, which is our 2 times our time, which is the 5 years, like that. So we are going to have our A is equal to 700 times 1 plus our 6 divided by 2 is 3%. Then we have times, or to the power 2 by 5 is 10. So we are going to have our A should be equal to 700. Then we have times our 1 plus 3% is the same as 3 over 100, like that, to the power 10. So we have our A should be equal to 700, like that. 1 plus 3 divided by this, it will be 0.03, like that, to the power of 10. So our A should be equal to 700, like that. Then 1 plus 1.03, it is 1.03 to the power of 10, like that. So this is the answer that we can write there. We cannot expand further because we don't have the calculator. So basically that is how we find that. So make sure that you know that 3 over 100, same approach, 0 point, you add a 0, it will be 0. 300 divided by that, that's how come I had that value. Then compound it quarterly. Quarterly means 1 over 4. Quarterly, in a month, in a year there are 12 months. So you say 1 over 4 times 12 is 3. So this 3 means every 3 months they have to compound, or rather add money. That means to say, if you just see quarterly, it means to say they have to compound 4 times in a year. So we are going to say that using the same formula, since it is not once, principal times our 1 plus our R over N. Just make sure that you know to say, your so we have our NT there. So we are going to say our principal is 700. Then we have 1 plus our R, which is our 6%, over our 4. So we have to the power 4, which is our N, times our T, which is equal to 5 years still. So we have our 700 times 1 plus 6 divided by 4 is we are going to get a value that will be equivalent to, so here we have 2, here we have 3, so we have our 3 over 2% there. Then to the power 4 by 5 is 20, like that. So this gives us a 700. This gives us a 700 times 1 plus so 3 over 2 is the same as 1.5. We have the percent there, then we have the 20, like that. So this gives us 700 times our 1 plus this percentage is the same as having the 0.015 like that. Then we have to the power 20. How am I able to do this? 1.5% over 100% gives us, so let me remove the percentages since they will cancel. So we have 1.5 divided by 100 is, we have a 0 like that. Now if we add another 0, it means to say it will move like that. So 15 divided by 100 is still 0 like that. Then we add another 0. 150 divided by 100 is 1. Remainder will be 50. 50 add a 0. 500 divided by 5 is this value. So this is what we have. So we are going to get 700. 1 plus this gives us 1.015 to the power of 20 like that. So this is our value for that problem. Let's move on to our next problem. So if it is compounded continuously, this becomes now the exponential, meaning to say it is being compounded for many times which we do not know. So this one we use our A is equal to P E R T like that. So if it is being compounded continuously, this is what we are going to be using like that. So we are not going to derive how this formula comes about, but we are just going to go direct like that. So let's answer the question. We have this one. What amount will an account have after 2 years if 5,000 is invested at an annual rate of 8%? So compounded daily. If you are compounding every day in a year, in 1 year, that means to say you're going to compound about 365 days like that. So therefore, this means that we are going to get something like this. So it will be our A is equal to principal. Then we have 1 plus our R over the N to the power of our NT like that. So this gives us a value of our A is equal to, what is our principal? So the amount, if 500 is invested, so 5,000, so we are going to say 5,000 times 1 plus our interest rate is at 8%, so we have 8% over, what is our N? Our N is the number of times, which is 365 like that. Then we have our N. Our N is equal to, what do we have for N? So the N is 365 times the number of years, it is 2 years. So this is what we have. So we have A is equal to 5,000 like that, times we have 1 plus our 8%. Remember, this will just be 0.08. By now you know how to convert. So we have 365 like that. So this is basically what we have. Then to the power of 365 times 2 is, we are going to have a 730. So if you do this times your 2, this will give you 5 by 2 is 0, remainder 1. Then 2 by 6 is 12 plus 1, that's 3. 12, 2 by 3 is 6 plus 1, that's 7. So we have the 730 here. So we are going to just simplify things. So our A is equal to 5,000 times our common denominator is 365. 365 by 1, it will be 365 plus we have this divided by this times that, it will just be that value, because 365 divided by 365 is 1 times this, it will just come back. So our A is equal to 5,000 times our 365.08. So just adding this normally, you can struggle with that. Then to the power of 730. like that. So we can if we are given such a question, we can end here. So just a confirmation, if you have this plus the 0.0800, this gives you 0 plus 8, it is 8, 0 plus 0 is 0.563, like that. So that's how come we had that. So this is the answer for compounded daily. Then if it is compounded, if immediately you see continuously, it means to say it is an exponential. Exponentials continually increase like that. So this is mainly the application there. So we are going to have our A should be equal to principal times our rate, which will be equal to, we have principal times the exponent to the power rate times our time, like that. So with this, what we are going to get is our A should be equal to what is our principal. So our principal is equivalent to, we had a 5,000 times E, then the rate is equal to, we have 8%, like that. 8% times the time, which is 2 years. So our A is equal to 5,000 E, then our 8% is the same as 0.08 times our 2. So our A should be equal to 5,000, then E to the power of, so if we multiply our 0.08, just remove the zeros, multiply normally, we have our 8 by our 2, which will be equal to 16. Now look at the number of zeros that you ignored. You ignored 1, even 8 itself for you to move there. So that means to say you have to move back 2 zeros. So we are going to have a point like that. So we are going to have a 0.16 like that. So this is the answer for that one. Let's move on to our next problem. So let's say we have barium 140 as the half-life of 13 days. If there are 500 milligrams of barium initially, how many milligrams will remain? So we have this as our formula there. So we are going to say, so know what it means. So Q is the amount that is remaining. Then this other QO is the original. Just think of it as O as the original or the initial. Then this N is your half-life. So this is your half-life. Then this T is the time taken. So how long does it take? That's your time taken. So that will be your time taken, like that. So you're going to say your Q should be equal to, what is our Q0? So the initial is 500 milligrams. So you have 500 milligrams times, we have the half. Then what is our T? So the time is 26 days. So you are going to get the 26 days and put them there. So we have the 26. So this time is for time taken. Then over the half-life, which is your N in this case, is the 13. What you can just know is half-life is always the denominator. So we have our Q should be equal to 500 milligrams, like that. Then we have to the power of 1 over 26 divided by 13 is a 2, like that. So our Q in this case will be equal to 500 milligrams times, we have 1 squared is 1 over 2 squared is 4, like that. So dividing, we are going to get our 500 divided by 4. It is 5 divided by 4 is 1. So the remainder is 1. 10 divided by 2 is 10 divided by 4 is 2. Remainder is 2. 20 divided by 4 is 5. So we have 125. So our Q, the remaining will be 125 milligrams, like that. If you look at the next one, it says after 52 days. So our B for 52 days, we are going to get something like this. So we have our Q should be equal to Q0 by, we have our q0 by half to the power of time over the half-life. So we have our q should be equal to the q0, which we are starting with, is 500 milligrams, then times half. If it takes how many days? We have 52 days, so we are going to say 52 days over the n, which is equivalent to the half-life, which is 13. So we have our q should be equal to 500 milligrams, then multiplied by we have our half. 52 divided by 13 will give us a 4, like that. So what we have is our q should be equal to 500 milligrams, then times 1 to the power 4 is 1 over 2 to the power 4 is a 16, like that. So remember, the 4 can enter into 16 and 500, which we said that 4 can enter into 500 125 times. So we can say q should be equal to 125 times, so 125 milligrams times 1 over 16 divided by 4 is a 4. So we have our q should be equal to 125 milligrams over the 4, like that. So this is basically what the value of our q remaining will be, like that. Let's move on to our last part for this one. So if we have 100 days, so under 100 days, what are we going to do? So same approach, we are going to say q should be equal to, let's put 100 days. So it will be q should be equal to q0 by our half to the power of t over n. So this gives us our q should be equal to, we have what is our q0. So our q0 is equivalent to, we have 500 times, we have 1 over 2 to the power of 100 over the 13, like that. So milligrams. We can end here since we don't have the calculator. So that is where we can end. You cannot do anything here. So let's move on to our next question. So we have the number of grams of a certain radioactive substance present after t hours is given by the equation. We have our q should be equal to q0 times e negative 0.45 t, where q0 represents the initial number of grams. Then we are told how long will it take? Will it take 2,500 grams to reduce to 1,200, given that the ln of 1 over 2 is equal to this value. So how are we going to answer this one? So they have told us that the number of this is given by this equation, where q0 represents the initial number of grams. How long will it take to, will it take 2,500 grams to be reduced to the initial number of grams? How long will it take for this to be reduced to 1,200? So this is the reduced. So this is the reduced. Then this will be your initial, which is your q0, like that. So we are going to say q0 is equal to 1,250 should be equal to this, sorry, just q is this one. Then we have our q0 is 2,500, like that. Then we have our e to the power of negative 0.45 t, like that. So then what are we going to do? So we are going to say that let's divide this value 2,500 over 2,500, like that. So as you can see, this 1,200 is if you have 1,250, if you multiply by 2, you're going to get 2,500. So this will be 0, this by this will be 0, remainder 1, this by this 4 plus 1, that will be 5, this by this, it will be 2. So that means to say here we are going to have our 1 over our 2. So we have our half should be equal to e to the power of negative 0.45 t. So we have after you have this, so we have the half should be equal to e to the power negative 0.45 t. We are going to introduce the ln on both sides. So the why introduce the ln? We are introducing the log, the natural log of ln like that, so that it can be able to cancel with this e. So you introduce it on both sides like that. Then according to the rules of logs, if you have the power, it will drop like that. So this will give us, and we are told that the ln of half is a negative 0.636, so negative 0.693 like that. So this should be equal to, we have the negative of 0.45 when it is dropped like that. Then we have the ln of e like that. So with this done, we know that the ln of e is equal to 1 like that. So we are going to have our negative 0.45 t, then we have times our 1 like that. So you put this comment, but the ln of this is equal to 1. So negative 0.693 will divide the negative 0.45, negative 0.45 like that. So our t should be equal to, we have this and this cancels, we have our 0.693 over 0.45 like that. So this gives us this value. So now to get rid of the decimal point, since this one has got 3 numbers, multiply by 1000 on both numbers. So what you do on top, do at the bottom, or vice versa. So we are going to have the decimal point will move 3 times. So we have 693 over, then this one, it will be 1, 2, and another one, so there will be an addition of a 0. So we have over our 450. So this is our time like that. So this is our time. Moving on to our next problem. So this is the time that they wanted. Moving on to our next problem. So we have the number of units n of electricity used by the household after t months is given by this formula, where k is a constant. Then we are told find the value of k. Find the value of k if 270 units were used by the household at the end of 1 month. So we are going to say, we have been told that our n is equal to 30 times 1 plus our e to the power of kt like that. Then we are told that 270 units were used. So we are told that also the number of units n of the household of electricity used by the household at t months. So n is for the number of electricity used. Now we are told that, so at the end of 1 month, we are told that the household after t months, so we are calculating in months. So we can just be able to say our n is 270 should be equal to 30, 1 plus our e, then we have our k, and then we have our time, which is 1 month like that. So we have the 270 should be equal to 30. In fact, so 30, 1 plus our e to the power of k times 1 is just k. We divide by our 30, we divide by our 30. This is going to give us a value that will be equivalent to 9, which should be equal to, we have 1 plus our e to the power of k. So in fact the brackets will go. So this is what we have. So taking the one the other side, it will be 9 minus 1 should be equal to e to the power of k. So 9 minus 8, or 9 minus 1 is 8, should be equal to e to the power of k. So from here, as long as you have the e, introduce the ln like that. So introducing the ln, we are going to have ln 8 is equal to, this k goes here, we have our k ln of e. So we know that, but the ln of e is equal to 1. So we are going to have our ln of 8 should be equal to our k, then we have our 1 where ln is. So we have k should be equal to the ln of our 8 like that. So that is our value for that one. Then the next part says find in simplified form the exact value of the number of units used by the household at the end of 3 months. Do not leave your answer in exponential form. So how do you solve this one? So knowing that the formula that they have given us is n is equal to 30, then times we have our 1 plus, is it 1 plus e to the power kt, e to the power kt like that. So what we are going to do is we are just going to replace. So we have our 30 like that. So how many are used, meaning we are looking at n. So we have 1 plus, we have our e, then what is our k value? So k, remember k is equal to the ln of 8, so we are going to put the ln of our 8, then we have times our t like that. So now this is where the magic comes in. So this is the way it is. So all you are going to do is we have our 30. Remember this, when you have the power like that, what you're just going to do is that just look at the number and look at this t or the preceding number. So if you get this, make it your power. So this is how the rule works. So just get this and say we have plus the one that is, so we have open brackets 1 plus, so as long as you have e to the power ln, you are going to say that this will just be equal to, okay, so let me represent the work like this. So just say but the e to the power of ln 8 times the t should be equal to, you are going to have your, this one will become your base, then the power will be your t like that. So this is what we do to such equations. So that is what we do to such equations, as long as ln is the power. So we have our n should be equal to 30 by 1 plus, we have our 8 to the power of t like that. Then we have our n should be equal to 30, 1 plus 8 to the power. For how long? We have been given that for used at the end of 3 months. So we are going to put our 3 like that. So 3 months, we are going to put our 3 like that. So this gives us our, knowing that our 8 to the power of 3 is equivalent to 8 times 8 is equal to 64. Then our 64 times our 8, this gives us 4 times 8, it will be 32. So it will be 2 remainder 3. Then 8 times 6 is 48 plus 3, 48, 49, 50, 51. It will be 512 like that. So we have our n is equal to, we have our value which is our 30, open brackets 1 plus, we have our 512 like that. So our n is equal to 30 times our 1 plus this, it will be 513 like that. Then just multiply. So this is what we have. So let's now multiply. So our 513 times our 30. So the key trick is just get this 0 and put it here. So let the 0 be there. Then you're just going to remain with 3. So we have 0 by 3 is 0. 3 by 3 is 9, 3 by 1 is 3, then you have your 3 by 5 is 15. So you can only do this if you have a 30, you have a 40, you have a 50. As long as you have zeros, you can throw it to one of the numbers. So this is our value. So our n should be equal to 15,390, like that. So do we have any other problem here? So our C, so these are very examinable questions. So we have our C. So for our C, it says that how long will it take 2,000 to double itself if it is invested at 13% interest, compounded continuously? So the key term is continuously. So we are going to say that this will be, our A should be equal to, we have the principal times E rates times the time, like that. So that is what we are going to get since it is continuously. This is the equation. So we are going to have our A. So if it is doubled, that means to say A will be equal to, so A doubled will be equal to, we have our 2,000 times the 2, which will be equal to 4,000. So this is, we are going to have our 4,000 should be equal to what is our principal, which will be 2,000, like that. Then times our E times our R T, like that. So with this, we divide our 2,000. This gives us a value of 4,000 divided by 2,000. We are going to get a 2, which should be equal to, we have our E times our R T, like that. So we are finding how long, meaning we are finding time. The rate is 13%, so we can substitute. So we have our 2 should be equal to E to the power 13, where there is this, so we have 13t, like that. Then introduce the ln on both sides. So the ln of 2 should be equal to the ln of E to the power 13t, like that. Drop the 13, like that. So we have the ln of 2 should be equal to, we have the 13t ln of E. We know that, but our ln of E is equal to 1. So this gives us the ln of our 2. So this is 13%. Be careful, not this mistake I've made. So this is 13%. This is 13%, like that. So we have the ln of 2, which should be equal to, we have this should be equal to, we have 13% times t, like that. So 13% is the same as, we have the ln of 2 should be equal to 13% is the same as 13 over 100, like that. Then we have times our t. From here we are going to cross multiply. It will be 13 times the 1, so it will be 13t should be equal to, this 100 you are not going to multiply by 2, but it will come in front, so it will be 100 ln of 2, like that. We divide by 13, so our t should be equal to 100 ln of 2 over our 13, like that. So this is our time. So this is what we have. So expect such questions. So this can carry 5 marks. Then this one, at what rate of interest compounded continuously will an investment of 5,000, will an investment of 500 to 1,000 in 10 years? So same approach. So the key term is continuously. So from 500 to 1,000, meaning you are beginning with this. You are beginning with a small one. It's a business. You don't expect to be going backwards. So our A is equal to principal. Then we have our RT, like that. So we have 1,000. For you to reach 1,000, then we have the principal, which is 500, like that. Then you have our E. Then what is our area? Our area is what is our area? So at what rate? So we have the time, which is our 10, so we can put the 10, then we have our area, or if you want you can begin with our area times 10, but which is still the same. So divide this, we are going to get 1000 divided by 500, it will be 2 should be equal to e to the power of 10 area, like that. Introduce the ln on both sides, so we have ln of 2, ln of e to the power of 10 area. So this will be able to be dropped there, so we have the ln of 2 should be equal to 10 area. Then we have the ln of e, we know that, but the ln of e is equal to 1, so we are going to have the ln of 2 should be equal to 10 area, like that. So we divide over our 10 like that. So our rate should be equal to the ln of 2 over the 10, like that. So that is basically what we have for that one. So that is what we have for that one. So that's our rate right there. So there's nothing that you can be able to do, because this is simply because you don't have the calculator. Then our final question, which mostly comes in an exam, is this last one. So we have the sales S of a new product after it has been on the market for T years is 30,000. Then we have this. Then we are told find S as a function of T if 500 units have been sold after 1 year. Now remember, S is the sales of the new product after T, which is in years. So we are going to say our S is equal to 30,000, like that. Then we have 1 minus e to the power of kt, like that. So we are going to take our S is the 5,000 should be equal to 30,000, 1 minus our e times our kt, like that. So we have divide by our 30,000, divide by our 30,000, we are going to get so we have these zeros go, then our 5 over 30 is 1 over, so 5 can enter into 36 times, so we have 1 over 6 should be equal to, we have our 1 minus our e to the power kt, like that. So we take this one this side, this is going to give us our 1 over 6 minus 1 should be equal to negative e to the power kt, like that. So this gives us, common denominator is 6, 6 divided by 6 is 1, times 1 it will be 1, minus 6 divided by 1 is 6, times 1 it will be negative 6, should be equal to negative e to the power of kt, like that. So our 1 minus 6 gives us negative 5 over our 6, which will be equal to negative e to the power of our kt, like that. So since there's negative on both numbers, you can multiply by the negative 1. If you want, you can divide by negative 1. It is still the same. So negative by negative is positive, should be equal to a positive kt, like that. So from here, we want to find S as a function, meaning to say you need to first find your k after 1 year. So time is known, so we are going to put our 5 over 6 should be equal to, we have our e, then k, our time is 1 year. So this is what we have, 5 over 6 is equal to e to the power k. So we introduce the ln here, so that ln of this, k will drop there. So we have our ln of 5 over 6, so we have should be equal to our k. Then we have our ln of e, we know that, but our ln of e is equal to 1, So our k value will be equal to the ln of our 5 over our 6, like that. Last but not the least, we have this one, also the expression. Since they wanted the expression, we have our s is equal to this. You just substitute the value of s as a function of t. So you just replace this same thing. Let me just write the equation here. So it will be s is equal to 30,000 open brackets 1 minus e. Then where there is k, you are going to put the value which is the ln of our 5 over 6. Then we have times our t, like that. So this is the expression. So knowing that this is the expression, we are going to take, so we have this as our equation. So this is the expression that they want. Then for this other part, find expressing your answer as a fraction in its lowest terms. How many units have been sold after 3 years? So using this same equation to find your b after 3 years, you're going to have your s should be equal to, we have our 30,000 times our 1 minus our e to the power of the ln of our 5 over 6. Then the time is 3, like that. We have the time 3. Okay, so before we substitute this, let's just maintain the time like that. So what we have is, so we are going to say our s is equal to, we have our 30,000, then we have our 1 minus. So remember, before we do this, remember the ln of our e to the power ln of a number such as 5 over 6 times the time is equal to, you are going to maintain whatever is here. It will be a 5 over 6, then this one will be, your time will be your power. So therefore, you are going to say your s is equal to 30,000 times your 1 minus, where there is this, you are going to put your 5 over the 6, then to the power of our t, like that. So this gives us our s is equal to 30,000. Then we have our 1 minus our 5 over the 6. Then we have to the power of our t, which is equivalent to our 3, like that. So we are going to have our s is equal to 30,000, like that. Then we have 1 minus, what is 5 to the power 3? So 5 to the power 3 is the same as 5 times 5 times our 5. 5 times 5 is 25 times our 5, which gives us, so 25 by 5 gives us a value that is equivalent to, so 25 by 5, it will be 125. So we have 5 to the power 5 is 125 over 6 to the power 3 is the same as 6 times 6 times 6, which is the 36 times another 6. So we put our 36 times 6. 6 by 6 is 6, remainder 3. 6 by 3 is 18, plus 3, it will be 21. So we have our 216. So we take our 216 like that. Then this one, after doing that, we are going to have our s is equal to 30,000. Then the common denominator here is 216. 216 divided by 216 is 1. 216 divided by 1 is 216 times 1. It will be a 216 minus 216 by this, or divided by this, is 1 times that, it will be 125, like that. So this gives us So this gives us our S is equal to, so let's subtract our 216 minus our 125. This gives us 6 minus 5 is 1. Then our 11 minus 2 is 9. Then we have, so we basically have a 91 there. So we are going to say 91. Then S is equal to 30,000 times our 91 over our 216, like that. So then we are now going to deal with this equation and simplify as much as possible. So simplifying this, let's start with a 2 that can easily be able to work. So if we take our 3, our not 3 but a 3 can enter into this, 3 can enter into 21 and 6. So let's 21 divided by 3 is equal to, we are going to have 7. 3 divided by 6 is our 2, like that. Then here 3 divided by our 3 is 1, so we have a 10,000. So this is what we have. So we have our S is equal to 10,000 times our 91 over the 72, like that. So being 72, we can reduce it by dividing by 2. So if we divide 72, 7 divided by 2 is 3. Remainder 1, 12 divided by 2 is 6. Even here, 10 divided by 2 is 5. Then we have other zeros, like that. So this gives us our S is equal to 5,000. Then we have times 91 over the 36. We can still divide a number. Now we know that 36, 4 can enter. 4 can also enter here. If you want, you can use a 2, but they want it to be in the simplest form. So 36 divided by 4 is 9. Then our 5,000 divided by 4 gives us 5. It will be 1, remainder 1. 10 divided by 4 is 2, remainder 2. Then we have 20 divided by 4 is 5. Then we have this. So this is what we have, 1,250, like this. So our S is equal to 1,250, like that, times our 91 over 9, like that. So we just now multiply, since no number can enter into these two numbers. So let's multiply. So our 1,250 times our 91 gives us, we have a 0, 5, 2, 1. We have 0. 9 by 5 is 45, remainder 4. So we have a 5, remainder 4. 2 by 9 is 18, plus the 4, it will be 22. So we write 2, remainder 1. Then 9 by this is 9, plus the 2 that remained after. Adding this 9 times 2 is 18, plus the 4, it gave us a 22. So the remainder was 2. Then this by this is 9, plus the 2, it will be 11. So if we add this, it will be 0, 5, 7, 3, 1, 1, like that. So this is what we have. So we can say S is equal to 11375 0 over the 9. So this is our answer for that one. So that is that for application of indices and logs. Thank you very much for watching. Hope you would like, subscribe, and share for more. See you in the next tutorial.